Video is an example of Hess's law to show you how to do it. Okay, I've written out a problem here. You can pause the video and write it down. This is the equation. The overall equation is the one that you are wanting to get, and you get that equation from these two here. You can either flip the equations to get the desired. You can either flip the equations to get the reactants that you need on one side and the products that you need on the other side. And when if you flip them, then that means you have to change the signs of the heat changes too. Like if it's positive and you flip it, then you have to change it to a negative. And if it's a negative and then you flip it, then you have to change it to a positive. And then if you need to multiply the whole entire thing by like a number to get a certain amount of number in the front, the subscript in the front, then you also have to multiply the change of heat. Okay, so for this one, to get the N2 in the reactants, and then to the products yields 2NO2, we have to look at our equations. Okay, so the first one has N2 plus O2 yields 2O2. Okay, well, we have the N2 and the O2 in the reactants, so that's good. So I'm going to put a check mark by them like that. That's what we want. And then we have the 2NO, but that's not what we want in the product. We want 2NO2 in the product. Okay, so we're going to look at our next equation. It says 2NO2 in the reactant, and then yields 2NO plus O2. Okay, so we have the 2NO2 in the reactant here, and we want to get that in the product, so we're going to flip it. Okay, flip. And you're going to do 2NO plus O2 yields 2NO2 delta H equals negative 112 kJ. And it's negative now because you flipped it. And I'm going to cross out the equation before because we don't need it anymore because we have our new one right here. So now the 2NO2 is in the products and the O2 and the NO is in the reactants. And we changed our positive sign to a negative sign. Okay, so now we have the 2NO2, the O2s, and then these, the two NOs can cancel because this one's in the product and this one's in the reactant. Yeah. So they cancel out because we don't need those. Because our overall equation doesn't have those in there. So you just cross them out like that. And then the O2s can add up because you need 2O2, and they can add up because they're both in the reactants. So you'll have 2 plus 2O2Gs. And then you have the 2NO2s in the product. And that is your overall equation. Right there. So you've got that. So now what you do to find the specific heat for the overall equation is you add the 180 minus 112 and you get 68. So the delta heat equals 180 kJ minus 112 kJ. And if it was positive, then you would add it, but you just sum them up. And then 68 kJ, that equals 68 kJ. So the delta heat for the overall equation is 68 kJ.